So first and foremost, I want to thank everybody here in this room for the privilege of your time. I know you have a choice of where to be, and you chose to be here with me today, and that is very much appreciated and respected. So I do want to talk about CloudXR, specifically talking about kind of what we do, how we're working with CloudXR, and kind of where we see it going. And then I also want to be able to highlight a real world use that is exciting with CloudXR, that has implications not just for sort of the actual project, but implications for us as humans. The project that is trying to be solved for is the quest for a clean source of energy. So it's an exciting thing, and we can show some awesome videos and sort of interactivity of how exactly it's being used and worked in that environment. The first thing I want to highlight, though, is the ecosystem for XR is massive. It's vast, and a lot of it is because of the great work of everybody in this room. And I want to thank you all for that. It's fantastic. One of the most important things at NVIDIA we want to focus on is kind of where do we see where we can do our best work, where our customers and our partners help us do the best work so that they can do their best work. And we've categorized 4 discrete pillars that are really important to focus in on when looking at XR enablement from NVIDIA. The first is artificial intelligence. We believe that when you work with AI, you're able to get direct inference of exactly what you're looking at or doing inside of your scene. If I'm talking and interacting with something, I should be able to do it naturally. If I'm dealing with an object like an automobile, that object shouldn't just be a mesh of geometry. It has physical properties, and I should be able to interact and work with those physical properties like I do with a real car. The other piece is collaboration. Technology that is made in a vacuum generally dies in a vacuum. You need to be able to work with other people. Other people help push each other to innovate and make solutions better, richer, more meaningful for them. And so innovative concepts through collaboration are vital for XR. The third is photorealism, and this is a key detail as well. We do not believe you should compromise on visualization for the sake of interactivity. When you work with content, you should be able to work directly with that content, and you should be able to interface directly with that content as if it was the actual object. And the last piece is streaming. Streaming is the delivery mechanism for a lot of great things today, and XR can make direct use of that streaming component. And there's some real advantage you get when you're able to offer solutions as a stream, and I'll go into more details of that specifically. Now, the most important concept here is when we build products at NVIDIA, we ask ourselves, what is the soul of the product? What is the SOL of the product? And we reference that as the speed of light. The speed of light means the best. It means that pinnacle in which you've achieved either the fastest, the greatest, the whatever term you want to use for your product or solution. And so we have to start asking ourselves as a collective group here, what is the speed of light for XR? What are some of the things that we need to do well in order to make XR achievable, to make XR grow? For us, the other thing that's interesting to understand about traveling at the speed of light is the closer you get to the speed of light, the more things change, the more rules are kind of different. When you get closer to the speed of light, the way things that were historically done maybe don't apply anymore. Maybe you have to start looking at things a little bit differently and trying to do things a little bit differently. So when we look at XR, we've identified 3 core components that are required when traveling near the speed of light. The first is when you work with something, it must be realistic. When we're talking about the object, the data, and the way you interface with that information. I mentioned the car earlier. This could be any object. Maybe it's a door, or maybe it's a piece of furniture, or maybe it's an item. When you work with those objects, you must have a realistic handle on what they do. The suspension of disbelief cannot exist within an XR ecosystem. The second is you must work across all devices. Our customers and our clients are working on a multitude of differing devices, be it tablets, be it headsets, it doesn't matter. Frameworks that get created should transgress all of those devices as best as they can, because those are the ways our customers and our users and our developers are going to be working with. And the last piece is your solutions must be globally available. You have to meet your users and your customers where they are. You have to then offer solutions that are where they are. And that means taking advantage of globally available infrastructure to deliver that experience. Now, this is a lot to have a realistic experience that's device agnostic and globally available. And you have to ask yourself, well, how do I achieve this capability? And the reality is we have a model today where this is possible outside of the XR realm. And that is with the data center as a core component of delivering that capable experience. In fact, we say we're in a new unit of computing using the data center as a key critical component. And so with the data center, I have the ability now to take advantage of on-demand compute, storage, and network to deliver experiences to end users, to developers, to customers. And it becomes really important and necessary to start asking yourself, what sorts of new work can be achieved when you start working in this manner? And it is that sort of kind of hope and that sort of goal of why we launched CloudXR in 2019. NVIDIA CloudXR is an SDK that allows developers to take it and implement into their solutions. And it allows them to host their applications on a remote server, remote infrastructure that could be standalone or it could even be clustered. But that remote infrastructure then renders that experience and uses the network infrastructure that's already in place to deliver that to end devices and end clients. And when we released this for customers and partners and developers to work with as an SDK, the feedback we received was, it was great. They were building solutions with the SDK, and they were creating new lines of business, and brand new businesses were created as a result of this capability. Now, when you work with NVIDIA CloudXR as an SDK, it's really important too to realize you need to have an end-to-end relationship with the information. This is the only way you're able to achieve true data center scale within your applications you're building for. And so NVIDIA CloudXR is the end-to-end solution on devices, networks, and applications. When we talk about devices, I hinted on it a little earlier, we're talking about enabling all-in-one devices, equal fidelity of tethered peers. We're talking about taking devices that are off the shelf and making them first-party citizens in experiences that are delivered remotely. We're also talking about providing a unified environment that allows developers to build regardless what their medium is. For example, if I'm an augmented reality developer and I'm building an AR experience with my tablet, I should be able to use the same code base or the same SDK as somebody who's looking to build a virtual reality experience with a headset. If I'm building AR experiences, obviously my video fields are different. You know, I have effectively one screen. If I'm a VR developer, I have two for each eye. You should not have to worry about the minutia of figuring out how to write code for an augmented reality or virtual reality experience. It should work regardless out of the box. When we talk about networks, we're talking about taking advantage of quality of service that is built into the networks to work over a variety of differing conditions. We're building on nearly 10 years of experience of leveraging GeForce Now to deliver our game streaming service and adding XR capabilities on top of it. Now, this capability has allowed us to now use networks that are a variety of different types of networks. We're talking about 2.4 gigahertz Wi-Fi, 5 gigahertz Wi-Fi, 5G networks, and then we're talking traditional internet networks as well, for being able to traverse across the internet where you don't necessarily have direct control of your end-to-end nodes. As a developer, you shouldn't be concerned with the minutiae of how to optimize that. You should just be able to write your application, connect to a client, and then know that the best effort being made is being done with the application. And then the last piece is the actual application integrations themselves. So I spoke about it being delivered as an SDK. What we're talking about here is slipstreaming into the developer's workflow. As a developer, you have a specific pipeline that you work with for continuous improvement, continuous deployment, and you need to be able to have an SDK that can work without doing a rip and replace. Rip and replace is not an option when you start working with large infrastructure projects like architecture, engineering, and construction projects. Being able to take an existing workload that you're familiar with and know how to integrate an XR delivery package to it that is remotely hosted is critically important, and not necessarily have to change your process in order to do it. So I want to focus a little bit on the actual sort of use case we have here, now that we've kind of explained a little bit around what CloudXR is, why we're doing what we're doing, and specifically how it's being done. And I want to introduce you to a partner, Bentley Systems. Bentley Systems is one, if not the largest, civil engineering firms in the world. They build big things. We're talking big bridges, big tunnels, big towers, incredibly massive structures, generally for the benefit of humanity. Specifically, this example is using the client ITER, I-T-E-R, and they've been in the news lately actually, is a conglomerate of nations who are attempting to build the world's largest tokamak. For those who aren't familiar with what the tokamak is, effectively is a fusion reactor. And it's an attempt to effectively create the way of harnessing clean, renewable energy on Earth, effectively emulating the same sorts of systems and the same sorts of reactions that happen on the sun. What you have is effectively a big donut, and in the middle of that donut is where the actual reaction takes place, the fusion reaction takes place. Surrounded on the exterior of it are a series of magnets that attempt to kind of contain the reaction so that it can last long, so the energy that is created from fusion could actually be harnessed. These are massive projects, and this project's been going on since the mid-90s. And what Bentley was asked to provide was a life model or a life interactive experience that allowed ITER's scientists, physicists, engineers to be able to get true to life scale of what this actual build is, be able to do actual real science and real engineering within the model, use off-the-shelf components to get access to it, and have it be delivered anywhere in the world. And because because ITER has multinational reach, it was essential that it had an agility and scalability component to wherever their scientists and users are. The other key component for this is, again, going back to the pipeline of being able to work with assets, Bentley was not allowed to do anything with the models that they were provided. So these models are engineering models that are true to life with about 3 millimeter air tolerances within them. These models are made to be built from. These are not models that you generate and use when you're looking at representations. These are the true-to-life engineering models. And so an engineering PLM system becomes a key critical component inside of this infrastructure. And being able to interface between traditional PLM systems and the actual compositor sort of game engine worlds is absolutely necessary. Because CloudXR is delivered as an SDK that slipstreams right into the process, once the actual assets were put into, in this case, the compositor game engine, Unreal Engine, when the application was built with differing interactivity components within it, by playing that application on a remote server, it was able to be streamed to CloudXR client devices. And in this case, they chose the MetaQuest 2 headsets, simply because they were readily available. And so I want to show some of the videos of kind of what we're looking at here. So what you're seeing on screen here is a wire mesh of the assembly hall for this tokamak. And what you should get from this really is just the pure density of this model. And actually this middle part right here is the fly-through of the actual reactor core. But these are as-built engineering models that are unbelievably complicated to work with. What the Bentley team was able to do was take that model and use an Oculus Quest 2 to deliver it on remote data center infrastructure for their scientists. So what you're seeing here is the same scene with a navigation mesh put inside of Unreal Engine, but with the same model, looking at it through an Oculus Quest 2, tetherless over a wireless network. You have 32 million triangles in here, and you have 13 million of those unique, with over 1.7 million discrete objects in this model. It is an unbelievably massive model with no decimation at all, no optimization at all. The only thing added effectively was the navigation mesh to be able to navigate and walk around this model. So this is kind of cool to actually walk around and see, but what about actually doing real work within it? Let's show another example here. So here is the actual tokamak itself, the actual core. And within here, it's going to flip to a wireframe model, and you're going to just see, it looks like a blueberry. You're just going to see the pure density of this model after it pans and zooms out. Again, you're not able to make heads or tails around what you're seeing here, and these are just lines, but this is the work that was required, or this is the model that was required in order to offer this experience. Again, no decimation required, or no decimation was allowed for this project. And then the next video I'll play is that exact same model, again in a Quest 2, and I love it when this camera pans to the right here. You get real sort of lighting of this environment and the real sort of polish on the chrome looking at this model, again, navigating from afar with a remote headset using CloudXR to deliver that stream. And because this is a true-to-life model here, there's no LOD manipulation happening here. There's no level of detail manipulation. There's no decimation. And scientists and engineers can come into these models, validate fixtures, or fasteners, I should say, like what's being done here, and be able to do actual measurements from these sorts of models. This sort of workflow is not possible on direct device use. This is what's capable when you start looking at delivering XR experiences that are remotely hosted and streamed to end devices. So the next step in a lot of this involves scaling this solution. And when we talk about scalability, we go back to the data center. The data center becomes a critical component to allow multiple applications to be scaled to even multiple users. And those users could be anywhere in the world. And we're talking about traditional networks here, but you can also cascade it to even 5G networks here. Again, keeping in mind that NVIDIA CloudXR has quality of service built in that allows it to make the best use of what network is available. And so if you're working on now new work where you're looking at edge server components, where you're co-locating within a 5G data center, you're able to now have direct access to the 5G network to stream to your differing devices. It's a truly exciting time, and we have partners building great solutions with our SDK as a result. So what's next? What does it mean then for us, and what does it mean for you, and what you want to do in this sort of kind of space? First and foremost, the 4 pillars we have to go back to. When you talk about XR and traveling at the speed of light, streaming will get faster, AI will be much more integrated for users, collaboration will become omnipresent, and graphics will continue to look more real and authentic. But the key detail that is able to stitch all this together is the data center. And the data center becomes an integral component into enabling these capabilities. If you've not had a chance to work with NVIDIA CloudXR yet, you're in luck. You absolutely can, and we've made it even easier for you to get started. If you are a user of public cloud service providers like AWS, Google Cloud, or Azure, simply go to their marketplace and search for CloudXR, and within there you will find an already built server with SDKs available for you to leverage and use for your projects. Also, our partners at Pico and HTC have created clients for their developers to work with. And so if you are a developer on one of those devices and you would like to build those clients to connect to those server infrastructure pieces, I've posted some links below that will give you access to a GitHub repository for you to check that out. We've also provided an AR core sample that allows you to take our sample and use it to build on whatever tablet of your choice that leverages AR core. And then you may say to yourself, well, if I'm an iOS developer or if I'm a MetaQuest 2 developer, what do you have for me? Well, we have this for everybody. Our developer zone becomes the place for more information, the latest versions, and everything you need to get started. And it's a great resource to join and be a part of. Our documentation is generally available and public. It includes code samples and snippets that you're welcome to leverage and use. And it describes the very sort of nitty-gritty of how to actually get started working with CloudXR as an SDK level. And then the last piece is our forum. And our forums are very active, and they include customers building solutions, partners building products, and then engineers and product managers like myself who are there to help assist along the way. And so what I want to do before I end my talk is go back to the first question I asked. And I said, what does it mean to deliver XR at the speed of light? And no matter if you're a content creator, if you're an application developer, if you're a device manufacturer, that's the question that all of us in this room really have to answer. And once we've identified what the speed of light is and the absolute best that something can be, then we can evaluate and chart a path that takes where we're at and charts a path to actually get there. And once we're all enabled in doing that sort of work, that really rises all boats and makes everybody benefit from the great work here. And the core data center component becomes all that more important into delivering an end-to-end solution. And so with that, I want to thank you again for the privilege of your time, and I've left some time for some questions if anyone has any. Thank you, everybody.
Hi, thanks for the amazing presentation. So I just want to know, for your Unreal to NVIDIA, are you using like pixel streaming directly, or what's the workflow if you can?
Yeah, so we are not using pixel streaming. Effectively what we're doing is any application that is, we're effectively hooking right into the VR runtime itself. So in that specific example, it was OpenVR, and any OpenVR application at that point is going to be able to be latched and streamed. So no pixel streaming, it's totally our sort of out-of-band solution.
Yeah, hi, great presentation. I had a question about your coverage of the photorealism in the specific example. And I know it depends on the use case, but it seems to me that there's a lot of engineering use cases where that photorealism, that kind of the lens bloom and the lens flare might actually be a distraction from an engineer's understanding of what those components are and what they're for. Just curious where that line is for NVIDIA, or if you studied when that's useful to have versus simply flat shaded, ignore the photorealism because there's a different kind of problem to solve.
Yeah, that's a good point. I think the key detail is it should be an option, but it's not necessarily the requirement. And so if my engineering needs for this day are more sort of object-oriented and specific, great. But at some point in time, even if I'm an engineer, I'm going to want to kind of know what this truly looks like. And I shouldn't necessarily be handcuffed and not be able to see that. And so that's really a representation of what the best could be and what is possible. And if that's important for my problem I'm trying to solve for that day, maybe I'm actually looking at where sunlight comes in if I'm an architect and I actually want to get true actual reflections so that I know where to place this house or place this building, then that sort of work may matter. And so it's about providing really options and choices for engineers to work with.
Okay, thanks.
You got it.
Hi. I love to admit this to a room. Sorry, I was a few minutes late to the presentation, so excuse me if you covered this already. But does this work for like secure data, or what levels of data that companies have when you're linking these from the cloud? How does that work?
Sure. So the key detail when it comes to enterprise security is flexibility, because most enterprises have differing ways of securing their data. So by offering CloudXR as an SDK, and if I have a hard sort of security requirement or even a compliance requirement, because a lot of times security and compliance get kind of mishmashed together. So if I'm working on, let's say, 3-letter agency work where I need actual compliance, then you're going to be able to integrate those sorts of solutions into a greater architecture that still stays compliant and secure as a result. So the idea here is provide a flexible, robust SDK so that you're able to take advantage of existing investments in your enterprise infrastructure.
Awesome, thanks.
Yeah, you're welcome. Great. Oh, you got one more? Okay.
One more quick one. So think about cost. So, right, like you've got essentially an instance per client when you're running applications in this way. How do you think about the cost? What are some of the ways that you think about like?
Yeah. So when you start, it really is again providing option and choice. So there's going to be instances and cases where you're going to make investments in your own enterprise data center, and you're going to actually put real capital into that effort. There also may be times where you want to take advantage of on-demand resources and maybe have sort of a variable cost associated model with it. So the real sort of way to answer that question is to look at the actual use case you're trying to solve for, look at the trajectory of the project, and then evaluate, does this make sense as a capital expenditure where I actually want to invest? And this might make sense if I'm, let's say, a data center provider and I have multiple people using this, or if I'm just working on a sort of single project that I want to be able to offer as a sort of a one-time sort of experiment or one-time use case. And in that scenario, you might just take advantage of some cloud infrastructure and pay the variable cost with it. Cool. Well, I think I'm getting the hook. So thank you, everybody.